Here's another fictional change in units kind of example, but I guess it could be somewhat realistic. So let's say we have a 15% solution of morphine. Now what that means is if you have 100 milliliters or 100 ounces or whatever you want to talk about it, 15 milliliters of the solution is pure morphine. The other 85 would be water or salt water, saline solution. All right, so let's say this morphine is being given at 10 cc's per minute through an IV drip over an 8-hour time span to a burn patient. You want to keep the morphine level pretty much consistent in this patient so he doesn't feel too much pain. How many cc's did the patient get in total over this 8 hours? And if the patient gets more than 0.75 liters of this medication in this 8 hours, they would be dead. So the question is, are they still alive? All right. So let's start off with, we really don't care about this part. The 15% of morphine solution, well, actually we do. But it doesn't become part of the conversion. It actually just becomes part of the answer. So what we're trying to convert is, we have here 10 cc's per minute. Now, from an earlier video, cc's is the same thing as a milliliter. Okay, because we're going to need that because down here, this thing, the total amount that would kill him is anything over 0.75 liters. Okay, so we have cc's that we need to change to liters, or milliliters we need to change to liters. We also have minutes and hours here. So when we get this mixture of same type of quantities but different types of measurements for them, for instance, minutes and hours are time, milliliters and liters are volume, but they're talking about it differently, we're going to have to do a lot of conversions. All right, so let's do an easy one. So we're going to do 10 cc's, which is the same thing as milliliter, so we can just do that conversion rather quickly. And we're going to do this every minute. So what we want to do is we want to convert milliliters into liters, and we want to convert minutes into hours. All right, so let's deal with the time, or the liters. Let's do with time first. It really doesn't matter which one you pick. So since we want to get rid of minutes, we'll put that up here. And we want to change it into hours, so we'll put that down here. And there are 60 minutes for every single hour. All right, the next conversion, so that'll get us our minutes into hours, is the milliliters into liters. So we want to get rid of this milliliters, so it's going to have to go in the bottom, since milliliters over here is in the top. And we want to convert it into liters. And there's 1,000 milliliters for every single liter. Milli means 1,000. So 1,000 milliliters make up 1 liter. So let's see what this is equal to. Type it into the calculator. Probably shouldn't have to, but hey, why not? 10 times 60 divided by 1,000 equals 0.6. Now let's go back and check our units, what's left over. So the milliliters are gone. The minutes are gone. And this is liters per hour. So this would be liters per hour. So this patient is getting 0.6 liters per hour of this 15% solution. Now we have to go back and do some other things. So if this is 0.6 liters of the solution per hour, that's not the pure morphine of the pure, I should say pure morphine here. Of the pure morphine. Now we're not talking about the entire solution. Over 8 hours, so we'd have to multiply this by 8 hours. Over 1 if you want to think about it. The hours will cancel and you'll be left with liters. So let's see, times 8. So this would be 4. My screen recorder crashed again. Now let's start off where we left off. So I rewrote the problem so it sounds a little bit better. How many cc's of morphine is the patient getting? And they are not getting 0.6 liters per hour, they're getting 0.6 liters per hour of the solution. Not the pure morphine, which I'm interested in. Alright, so there's a few things we need to do with this 0.6 liters per hour. we have to understand that the patient's getting it over an 8-hour period. So we have to do another little side calculation. So 0.6 liters per hour, and multiply that by the 8 hours. And the cool thing here is, even with this setup, the ratio setup, the hours are going to cancel. And it tells you exactly what you're going to be left with, which is liters of this solution. So this should be 0.6 times 8, 4.8. So this would be 4.8 liters of the solution. And we still have to convert this into pure morphine. And the morphine is 15% of all of that. All right, so to do 15% of the solution, it would be 0.15% of the, well, 0.15 is the 15 out of 100 of the morphine times the 4.8 liters for a grand total of, oh, let's see here, times 0.15, 0.72. So in the very end, you're getting 0.72 liters of morphine to this patient. And because he didn't match the threshold of 0.75 liters, he'll live, more than likely. He'll live, at least not because of the morphine is going to kill him. All right.